This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, follow us on LinkedIn. You'll find us there at the National Fluid Power Association. You'll get lots of updates on the podcast and other activities of NFPA. And when you're online, share those interesting and innovative uses of fluid power that you find with our hashtag #OnlyFluidPowerCan. If you see an interesting application of fluid power, you want to learn more about it, share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on all the popular podcatching services. Wherever you find us, subscribe to the show and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. Today's show is a special episode. We are commemorating the 10-year anniversary of NFPA's Fluid Power Vehicle Challenge. In each of the last 10 years, we've had students from universities around the country team up to simulate, design, build, test, and then demonstrate a vehicle platform powered by hydraulics and pneumatics. We give those teams a list of available components, requirements, and deadlines, and then we let them loose to demonstrate their creativity and their growing knowledge of fluid power concepts. The program kicks off in September and October each year, and then culminates in a series of races in the spring, with the final placement being determined by our engaged fluid power professionals looking for efficiency, speed and acceleration, regenerative braking, and sustained performance over time. This is a very novel application of fluid power, and it gives students an opportunity to gain some hands-on experience in designing and testing fluid power systems while they work with the constraints of timelines, project planning, and meeting a lot of professionals in the industry. As I said, this year marks our 10th anniversary of running this program. We hit an additional milestone with a record 32 universities participating in this exciting program. When we talk on Fluid Power Forum about interesting people who are moving fluid power technology forward, the students who participate each year in the Vehicle Challenge represent a very exciting future for our industry. So to celebrate this anniversary, we've invited three folks onto the show today. We have Dr. Jake Swanson from the University of Minnesota, Mankato, Dr. Brian Steward from Iowa State University, and Ernie Parker, recently retired from Hennepin Technical College, who has served as a longtime technical liaison for our program. And we're going to talk with them about how the program has evolved over time and how it prepares students to enter the fluid power industry. Jake, can you go first and tell us a little bit about yourself?
Yeah, absolutely. Hello, everyone. So I'm Jacob Swanson. I've been a professor of engineering with the Department of Integrated Engineering with Minnesota State University, Mankato for about the last 13 years. I've actually been chair of the department for the last 2, but I'm currently looking forward to a sabbatical in the upcoming year.
Yeah.
Our Twin Cities engineering program has participated in the Fluid Power Vehicle Challenge just the last 3 years. And it was only in the last year that I was highly involved. And my academic background is not fluid power, so this program has given me an opportunity to learn some new things, which I've really enjoyed.
Fantastic. Looking forward to chatting with you more about some of those early experiences for you and your teams in the program. But we also have Brian Steward on the line from Iowa State University. Brian, can you introduce yourself?
Yeah, certainly, Eric, and thanks for inviting me to be part of the podcast. I am a professor of agricultural and biosystems engineering here at Iowa State University, and I've been teaching fluid power engineering for 27 years. So it's been a little while, but that's been a constant teaching assignment, and it's been great to continue to develop that part of our program. And I've also been engaged with NFPA for almost that long,
Yeah.
and so it's been a real pleasure, and we really appreciate the industry support for our programs. It's really, really critical to what we do. I also teach computer-aided design and dynamic systems modeling and controls. My history with the Fluid Power Vehicle Challenge goes back to 2017 when actually the year before that, I was asked to be a judge. So I was a
Mm.
judge, and then the next year, I've helped found the team here. And so I really believe in these sorts of competitions for the development of students, and also serve as a mentor of a FIRST robotics competition that we host in the department as well. So
Right.
springtime is very busy for me.
Is there any time that's not busy for you, Brian? So it's
Yeah, I don't know. Yeah,
maybe 2 weeks in the summer, right?
maybe. Yeah.
Maybe.
So
Right.
yeah. Also, we went on to found the Fluid Power Club at Iowa State in 2019, and then in 2021 we were designated by NFPA to be a Power Partner
That's
University,
right.
which
Yeah.
again, thank you for that designation and recognition. I also do research in the agricultural equipment area, automation, robotics sorts of topics, and then machinery testing and modeling, and have provided leadership to the Iowa State University Off-Highway Vehicle Chassis Dynamometer Lab, or we
Yeah.
just call it the Dyno Lab, which we opened in the fall of 2022.
And if memory serves, Brian, we've actually done a podcast on that topic. We had you and one of your colleagues on the show to talk about that dynamometer.
Yeah, great, thanks.
Yeah. Well, great. And of course, not last but not least, we have Ernie Parker on the line with us as well. Ernie, please go ahead and introduce yourself.
Hello, everyone. Well, I guess we have a lot in common, all of us. I started in hydraulics in 1965 with school, and through a lot of divine intervention along the way, I picked up radar in the military and a lot of experiences from industry. And I taught for 43 official years, and then I went back for half a year to break in the new instructors, and then another semester teaching the certifications by the IFPS. And so I've been involved with IFPS and NFPA for many, many years. I enjoy it. I enjoy working with the students, and too many stories to tell at this time on this podcast. So been involved in a lot of things. So thank you.
Thank you, Marty. We'll certainly want to hear at least some of those stories related to the vehicle challenge. You, as I said in the introduction, serve as the technical liaison to the program, and we thank you for those efforts as well, given your vast background in hands-on fluid power exercises. But maybe I can start with the new kid on the block, if you will, Jake from Mankato. You said your team has just been in for 3 years now in this program. Maybe you can tell our listeners a little bit about what stood out to you, or what stood out to your students about the program when you first got involved.
Yeah, sure thing. So I want to be real careful not to gush, but really what stood out
That's
is
what we're here for, though. That's what we're here for.
Really the quality and the quantity of the support that was available for students. And so there was, for example, there was software provided, there was mentors, there was kind of training of the mentors, there was webinars, there was student-specific training. There were, there's a lot of fluid power activity in the Twin Cities where we live. So there was lots of opportunities to visit suppliers, do site visits, communicate with the suppliers and get, in-kind support from them as needed. And so, like I said, just really both the quality and the quantity of all of those different resources that were available for students really just kind of blew me away. And I have, I have a lot of, I have more familiarity with some of the SAE vehicle competitions, whether it's the Formula SAE car, or the Baja car, the solar car, and those are also awesome student competitions, but they're more on the spectrum of, go build a great car. Good luck. We'll see you back here in 6 months. And that's that's not what the FPVC does, where it's really substantial and continued support for students, as well as faculty advisors across that whole process. And so very fair to say, I wasn't really prepared for that, but of course, pleasantly surprised.
That's great. Yeah, I really appreciate that perspective. As you're describing, NFPA does a lot of effort to connect the students with industry directly through a lot of those programs. So it's important. Brian, I wonder if I can ask you. You've been involved since almost the beginning. It sounded like, based on what you described. What are some of the ways that you think this program has grown or changed over the 10 years that we've been doing it?
Yeah, I agree with what Jake said in terms of the tremendous support, and I've seen that support evolve and it just continuously improve over the years. So that's definitely something that has continued to just improve as we, as a community. We've learned what are the challenges that student teams face. They're pretty typical, and then how it's best to train them. So we've seen that, but I think that the biggest thing I've seen is just the scaling that's happened with NFPA taking it to 3 sites recently, where in the beginning for quite a few years it was 1 site and around 10 teams. So that's pretty amazing, I think. And just hats off to your staff, because spring is a very busy time for them as they try to, as all these things come together. It's pretty amazing. It's a huge effort, and I really appreciate that. Yeah. I mean, otherwise, I've seen the rules and how the rules have been formalized evolve through time, and how corrections have been made. And I think that's continued to get tightened up a bit. And, it's just been continuous improvement in the whole thing. So that's been good to see.
Well, it is, go ahead.
Yeah, and also I think that we're as a community, we're learning more about what works well and what does not work well technically for these machines, so that's fun to see. I just hope we continue to improve what the students are able to do with the different team, because it's a very tough challenge. It's a very ill-posed problem in a certain sense.
Right.
And that's what makes it interesting from a design challenge.
Well, I've seen, if I can just comment as well, I mean, an interesting part of it is it's a competition to a certain degree at the end of the day. And the students certainly bring a competitive spirit to the competition. So a lot of the rules changes over the years have been trying to stay ahead of that creativity, if you know what I mean.
Yes, I know what you mean.
Trying to make sure everybody's safe and has a good time, but stays within the rules, if you know what I mean. And some of that is just, like, as you said, is the technical challenges associated with it. This is not the kind of fluid power application that you're going to find in the real world. It's a very unique application of fluid power, given the flow rates and the pressures that we're dealing with in these kinds of applications. Ernie, I wonder if I can ask you your perspective on some of the common technical challenges that the students face, and how you've seen them overcome some of those challenges in your tenure.
Well, they sure get a lot of them. Number one is the design process to start with. Many of these students have never had any hydraulic or fluid power classes at all. Now, some of the professors like Jake and Brian here, they've got involved so they can help a little bit, but some of them have nowhere to turn except to the NFPA for help. And so designing is a challenge for them. Then sizing the components. Over the last couple of years, we come up with some easier ways to help them size. Ordering is always a challenge. They forget about time management. And I think this is one of the big things they learn, that when they get out in industry, they've got a time frame when it has to be done in, and they're not quite ready for how quickly that deadline comes.
Right.
And so when they're ordering, also ordering the right hardware, do they know the difference between the different valves and stuff, and a slight difference between a spool valve and a poppet valve? Both do the same job, but what happens internally is different. And then I think one of the biggest challenges is the physical building. Most of these students have never built anything with their hands. It's different than 20 years ago when you had kids that were working on cars and stuff like that. But these students, many of them never had a tool in their hand before. I've known some that couldn't even never screwed a bolt into a hole. And so it's challenging. And I think the rewarding part is I just love hearing the comments. I learned more in these 2 days than I did all semester.
Yeah.
And it's not that they didn't learn in the semester, they just weren't able to apply it until they got the hands-on, and they took all their learning that they kind of washed off and kind of blew off, and oh yeah, that makes sense now. And so it all ties together. And I just love seeing those light bulbs come on.
Yeah.
That's what makes it so rewarding.
Yeah, absolutely. I have often the same experiences when I'm on site and talking to the students about their journey, if you will. It's a light bulb moment for many of them, as you're describing. And maybe I can ask Jake, when you've seen your students get engaged in the program, what do you think about this idea that they're learning real world engineering, in terms of time pressures and those kinds of issues as well? Do you see that happening?
Yeah, absolutely. I guess I'd like to say that really, I think everything we're doing with the Twin Cities engineering program is helping to prepare students for kind of real world engineering, as you say. And we, programmatically, we have this project-based hands-on learning approach. And so all of our students are participating in team-based industry-sponsored projects. And so FPVC fits in really nicely for us because it's totally kind of aligned with that mindset. So, for students on the FPC project, that's awesome for them. But if not, they're kind of getting the same experience for, with a different project. And I guess maybe to get at your question a little bit better, it's things, some of which have already been mentioned, but the open-ended problem solving, the having to work within a budget and actually buy things, having to reach out and communicate with suppliers. And if you don't do that, you don't get what you need. Yeah. And then really, maybe most importantly, having to learn new things quickly. So like Ernie talked about in terms of, varying levels of preparedness, even if you had, a formal course in fluid power, you get on this project, and I promise you there will be a lot of new things you will have to learn and quickly within that time frame. And so the being able to learn, the developing the skill of having to learn new things quickly, I think is absolutely very transferable to the real world.
Absolutely. Yeah, one of the goals of the program is to help move the students from university into the professional world of fluid power. And Brian, I wonder if I can ask you if your perspective on that. Have you seen that happen, and does the program help students make that transition?
Yeah, Eric, it does. I've seen several of our students go to work in the fluid power industry because it starts to help them build relationships with fluid power industry professionals, I think, which is excellent because they get to kick the tires a little bit on the industry, and then they are learning to relate to industry professionals, and they get to see who are the best students coming out of these programs. So we also, because we have the Fluid Power Club at Iowa State, and also we've hosted a networking event with NFPA support a couple times. Those have been some additional opportunities for them to meet industry professionals, and out of that whole combination of the vehicle challenge and the club and the networking events, there have been several students hired by NFPA member companies, and I mean, they've been able to go after the really great students. I think the thing that would be great is if we could, and this is a challenge for all of us, is how to get younger students involved in that process, because often we have seniors working on the vehicle challenge, and by that time they have jobs already. So that's just a challenge of how to get younger students involved earlier. And we make we have some success at that. And then other years the students tend to be older, or, it kind of goes back and forth.
Yeah.
But it'd be great to be able to get in earlier.
Yeah, well, I mean, the Fluid Power Club that you talked about is at least one of the attempts to make that happen. To expand the exposure, if you will, of fluid power on the campus, so that the younger students can get they serve as kind of the farm team sometimes for the vehicle challenge team.
Exactly. Yeah.
But
I agree.
Yeah, I was reflecting on, as you were describing the transfer into industry that some of the students experience. One of the best parts of the program, from my point of view, is we actually have in the 10 years students who have been hired and who are now serving as coaches and mentors to vehicle challenge teams. In some cases, hosting the event itself. I guess I won't mention any names on the podcast, but we probably know who I'm talking about. So it's exciting to see that kind of transfer happen. Ernie, I wonder if I can go ahead, Brian. You had a comment on that?
Well, it's also, I think it's part of the culture, and it's very fun to watch some of those former students who are now working working in the industry, trying to telling their stories. And I remember some of those stories. There were pretty interesting things that happened back in the past, and so they are relating them to the students, and so it really creates some momentum and a kind of history and culture. So that's really special.
We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. Two of NFPA's most active committees are our two technology task forces, one focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. So, Ernie, I wanted to ask you, as I'm reflecting on what you were saying earlier about how this is often the first moment that the students have had any hands-on exposure to fluid power, sometimes to tools and construction themselves or in themselves. Have you noticed any changes in the skill level that the students are bringing, or at least to the degree of preparedness that they have over the time frame of the program?
Yes, I have. It's a different skill level. They're more skilled in the electronics and controls, 3D printing, and they're very much less skilled in the hands-on with the tools that they need to physically build something out of metal, machine shop skills and stuff like that. And the unfortunate part about it is when they've never worked in a machine shop of any kind or worked on cars, they don't know what's available to them. It's hard to design something when you don't know what you have for tools to actually put it together.
Yeah.
And I think that's the biggest challenge for these young students. And this is why they enjoy this program so much, is they're learning so much about just different tools. And even at the competition, watching other schools doing things, how they did it. I love seeing a hubless bicycle a couple of years ago. We've
Yep.
seen a unicycle in there, the creativity. They have a lot of good ideas. They just don't know how to put it together yet. And I'm hoping that we could get these students to ask the mentors and myself as more questions. Don't be afraid to reach out to us, because we're here and you can reach all summer long. It doesn't matter when you call, but we're here to give ideas. And maybe you have an idea to build something else. It's still going to help you learn besides the vehicle challenge. You'll get your more hands-on, more motivated to get into hydraulics. That's what we're here for. And we enjoy helping you.
Yeah.
So I want to pass that along to them.
Absolutely. Thanks for doing that. And as you were saying earlier, there's so many stories that we can tell about the student experiences in the program. Maybe I can ask, we can go around the room, if you will, and I'll ask each of you to kind of share a memory that really sticks in your brain as something you experienced in the program. Jake, can we start with you? You and your team at Mankato. What memory sticks out in your mind?
Yeah. So, well, as you know, I haven't had that long of a time to make memories, but the competition that we participated in last year, I guess something comes to mind. So it was in Rockford, and I think the first race was the sprint race,
Mm-hmm.
and I had a pretty decent sense of how my team was doing, and there were, and how fast the bike moved, right? Remember, this is my first time ever seeing this event, and there's a few teams that went through ahead of us, and some kind of puttered along, and some were maybe like, brisk walk kind of speed.
Yeah.
And I think I'm remembering it right, but then came Cleveland State, and their vehicle just took off like a rocket ship.
Yeah.
And it was so unexpected, and it was so cool to see. And it was like, wow, these vehicles can really go fast if you optimize them to do that.
Right.
And it was, and obviously that kind of speaks to the success of their design. Unfortunately, it wasn't my team that wowed us like that. And I won't say, I won't tell you what the outcome was of that sprint race unless you really want me to, but it was that's a memory that kind of really sticks in my mind, just because of how well that bike did in that race relative to everything else. And so the sheer performance was really fun to see.
That's great. Yeah, I mean, it is an exciting moment on the track when the vehicles start moving. I myself have seen the speeds increase over the years, right? As the designs become more efficient and become, optimized, as you said, for those particular races, they can go quite quickly down the track. So it's exciting to see. So Brian, how about you? What's a unique story or memory that you have about the program?
There's lots of memories being involved this long, and there's some not so great memories. Like our first year, we got up to the line, and the bike just would not leave the starting line. It worked back in the hall
Right.
of the building, and everything was flat. There wasn't any wind, but they just couldn't get off the starting line. But a favorite memory would have to be, and probably have some recency bias with this last year, we just had a very special team that bonded together well as a team, and they brought different expertise to the team. We had great leadership, and they really developed a very clean bike, and a bike that performed pretty well. And in the end, they won several awards and got second place overall, and that was very exciting. But I think the most rewarding thing was that our we have a departmental graduation event on graduation day, and so the students come with their families, and they're asked to introduce themselves and tell about the most memorable part of their 4 years here in their degree program. And
Mm-hmm.
there were, I think, 4 or 5 of our students who were graduating, and each one of them said that the most memorable part of their 4-year program was competing at the Fluid Power Vehicle Challenge. and they really embraced it, and it made a big impact on their life, and they will never forget it.
That's great to hear. Yeah, that you can feel that enthusiasm out there on the track sometimes. Certainly, that's a great story. Thank you, Ernie. What about you? What you must have a bunch of competing memories for something to talk.
Yeah, I don't
about.
even know which ones to talk about because there's so many of them. Like I mentioned earlier, the hubless bicycles. The first year was just one hubless wheel. The second one was
Yeah.
two hubless wheels. But I think one of the teams that stood out this last year was the Utah team, where the four gals had actually built the bike themselves, and the guy did the programming. He didn't touch the mechanics of the bike at all. To have a team do that well with four young ladies that have never built anything before was very amazing. I was out there earlier at an International Fluid Power Society meeting, which was only 3 or 4 blocks away. I said, I'm going to go over to the university and see if I can connect with them. They had nothing started at that point, just thoughts and how they pulled that together. And it's fun to see the teams work together as a team. And as Brian was saying, and Jacob, some of these teams just do an amazing job of working well together. They're not only work well, they're organized and everybody has their job, but they do it and they work together as a team. And when there's a failure on the track, they get right back on it, fix it, don't get discouraged, try it again and keep going. And they're so enthusiastic, and to see the energy at that competition is just marvelous. I enjoy it.
Yeah, absolutely. Yeah, that's great. I'm mindful of the time that we have here. We could talk about this program probably for hours. There's so much to say. We appreciate all of your participation on the podcast today. Maybe we can wrap up with, I'm sure there's someone listening who is in a position who might want to participate in this program in the future. We're always looking for more universities and more students to do so. Maybe I can ask each of my guests to give some advice to a prospective student or to a new team in the program. What is it that they should focus on, and what value will they get out of the program? Jake, can I start with you on that question?
Sure. So I guess if I was talking to a new team in their first year, I think the obvious advice is really try to embrace everything. So you're going to have the mentor opportunities, the networking opportunities, all of the people that want to help you. And, as Ernie and Brian have kind of already alluded to, take it, use those resources, take advantage of all of those opportunities, because it's, reach out and ask for help, because it is possible to kind of get through it and not ask for help, right? Not use the resources, not take advantage of all the opportunities that present themselves, because sometimes it's easier not to, and there's lots of competing priorities. And so again, it's really trying to embrace all of what's offered. And if I were, I guess, to say one more thing, or at least what I would maybe communicate to my team when they're new is kind of a friendly reminder that it is a competition, but I would frame it as it's primarily a competition, with yourselves. So you're going to be facing many different teams, and I think this is an potentially intimidating aspect of the competition. You're going to be competing against teams with varying resources and varying expertise, and in some cases potentially much more than yours, and potentially much less. And so you should really be setting your own goals. And as an instructor, I would be assessing your performance relative to the goals that you set, rather than versus the success or failure of other teams. And if you have another team that has an amazing bike that's way better than yours, but they break apart, they break their gear on the first race, and you end up beating them, and that's more their, in a sense, that's not really your success but their failure. And so again, it's a reminder that you're competing amongst other schools, but you're also competing against yourself, and you should be able to set your own goals for the competition and be focused on achieving those goals, rather than be intimidated by the prospect of being assessed against other people that are differently resourced.
That's great. Yeah. I mean, Jake makes the good point that it's always a slightly different and sometimes completely different group of students each year that are participating in the program. Brian, do you find yourself in a position where you're giving advice to new students or to a new team on what they can do to succeed? What do you tell them?
Yeah, I would echo what Jake said, that this is it is a difficult task that each team has in front of them, and so there is a tendency to get discouraged. But what is interesting is that when they come to the competition, they realize that, oh, this other team, they had the same problems we had. It's
Yeah.
at the and that they need to be encouraged to push through and do the best that they can in that process. So that's just part of it. And then another couple pieces of advice would be to just reach out to the community, because the technical advisors, the mentors, even other teams and advisors are very helpful and are willing to help. But we can't help unless we're asked for that help. So that'd be a big encouragement. And just one more thing is that plan for the tasks to take longer than they anticipate them to take.
Right.
Everything takes longer.
Yeah.
And I often tell my students that, oh, we're going to have, they'll say, we're going to have it together by this date. And I'll say, well, sure, you can have it together, but it won't work. And you need to plan for it to not to work.
Yeah.
And, that's just real world.
Yeah, absolutely. Yeah, we see that a lot, obviously, in the program. And Ernie, you're one of those technical liaisons that the students are reaching out to get feedback and get advice. I know you do that throughout each year in each competition. You're in a lot of contact with the students. What advice are you giving them? How are you best helping them to succeed in the program?
Well, I'll answer their questions first, but there's other things I'd like to do. Again, as both Brian and Jacob mentioned, start early.
Yeah.
Don't put off tomorrow what you can do today. Ask for help. Our industry is so willing to help and willing to donate if you just ask. We've got the best industry in the world out there to work with. And so don't be afraid to contact somebody. And then obviously leave a couple of weeks at the end before the ship deadline that you have time to debug it and get the bugs out of it. Something you might have overlooked, or a sprocket, as you mentioned, might have failed, or a chain or something like that. And so you've got time to fix the problems without being under stress. I'd love to see these teams come to the competition, open their bikes out of the crate or unload them, and they're ready to go. And that doesn't happen very often. There's always some tweaking, or they think about it. And so that's kind of the way it is. And so if they can start early, the stress level will go down. And we enjoy being asked questions. We don't mind it at all. And if they want some FaceTime in the evenings, that's good with me. I'll sit down with them anytime and walk them through some things and try to educate them a little bit.
All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Jake Swanson, Brian Steward, and Ernie Parker, who have been my guests on the show. If you want to connect with any of them, the best way to do that is via email, and we'll put a link to their email addresses in the show notes for this episode. I also want to give a shout out to Steve Gluck and Randy Nobles. They are also technical liaisons in the Fluid Power Vehicle Challenge. They've made significant contributions in supporting the student teams, as well as thanks to all the other academic staff and fluid power professionals who year in and year out contribute to the success of this exciting program. If you want to learn more, and we hope you do, go to our website, nfpa.com/Fluid Power Vehicle Challenge. At least you'll get to see a lot of videos and a lot of pictures of these exciting fluid power designs that the students are working so hard on each year. And if you want to get involved, we would encourage you to do so. Remember, if you like our podcast, please follow us on LinkedIn. You can find us there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We do want to hear from you about the kind of topics you want to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.